Welcome to this video. We're looking at fluid mechanics. So consider a tank which is filled and then it has an opening at the bottom, and we're asked to say, let us find the speed of the fluid at the smaller opening at the bottom. So of course we're going to apply Bernoulli's principle. We'll use Bernoulli's equation in trying to find the speed at point 2. So let's just say the bottom here is point 2 and then the top is point 1. Right, so Bernoulli's equation, we know it's P1 plus 1/2 rho P1 squared rho GH1 plus, or rather equals, supposed to be equals P2 plus 1/2 rho P2 squared plus rho GH2. Okay, so this is Bernoulli's equation. Now if we want to find the speed of this fluid as it goes through the smaller opening at the bottom, we need to consider first the speed at the top, the pressure at the top, and also the height of this fluid in the tank. Now at the top here, because the opening at the bottom is very small, the speed of the fluid at the top here is can be assumed to be 0, because the top part is very big compared to the smaller opening. The flow rate will actually be so small. Okay, so we assume the speed of the fluid at the top is also 0. Now looking at the pressure here, because the tank is open to the atmosphere, the pressure at the top is actually equal to the atmospheric pressure, and so is the pressure at the bottom. Okay, so the pressure at the top is equal to the pressure at the bottom, which is simply the atmospheric pressure, because both openings are open to the atmosphere. All right, so having that in mind, now we know that P1 is equal to P2, and we can simply cancel them out of the equation. Okay, P1, okay, let me just undo that. Okay, so P1 and P2 are equal, and also the speed at the top, which is V1, is taken to be 0, therefore this part is 0 in the equation. And the height H1, now this is the height of the fluid in the tank. So we have a value of H1, it's going to be given if you are given a problem. Now the value of H2, the height of this particular opening with respect to the top, is going to be 0 in this case. Okay, because the opening is right at the bottom of the tank, so the height is going to be 0, meaning that this guy also with an H2 goes to 0. Okay, then we remain with the equation as follows. We are going to have rho GH1 equals half rho V2 squared. So from this expression we will be able to find the velocity at the bottom. Okay, we find an expression for V2. We'll have V2 being equal to the square root. Okay, that will be the square root of 2GH1. Okay, so that is how you find the speed of the fluid as it goes out of the smaller opening at the bottom of the tank. So keep in mind those assumptions we made, and also take note of the pressures at the 2 points. So we are saying the pressure at the top opening is equal to the pressure at the bottom opening, which is equal to the atmospheric pressure. Also, the speed of the fluid at the top opening is actually 0, because the opening is so big as compared to the smaller opening, so the rate will be very slow. So we assume the speed is going to be 0 before the valve is opened. Okay, and also the height, because the opening is right at the bottom, the smaller opening, so to say, the smaller opening is right at the bottom, therefore the height, the reference height, is going to be 0 as well. But the height of the fluid in the tank is the H1 that we will be given. All right, so that's how you solve a problem in case you come up with a question that is of this nature: a tank with an opening that is right at the bottom of the tank. You can find the speed of the fluid at the bottom. Okay.